посвященный тестированию лексикона. Я хочу представить вам Майкла. Это известный кризисный специалист в области тестирования и работы с наследованным кодом. То есть, ну, понятно, что идет речь, да? У вас есть какая-то большая кодовая база, наследованная старая система. Очень частый вопрос, который возникает, что мы в этом случае делаем? Как мы внедряем это? Мы же не можем покрыть всю юнит-тестом, правда ведь? Это невозможно. Это бесконечное время займет, вообще говоря, с нулевым результатом. Но что-то все-таки можно делать. Какого-то, видимо, баланса достичь. И вот об этом Майкл расскажет мне. По поводу значит, мы попросили Майкла говорить медленнее, ну, понятно, не все, наверное, хорошо знают английский, да? Если у вас есть, как бы, вы не все понимаете, пожалуйста, задавайте вопросы сразу же, ладно? Если какие-то вопросы нужно воспроизвести, мы сразу же переведем. Потому что перевод постараемся сделать максимально понятно. Ну все.
Over here. This. Okay, this is a nice small group, which is good. That's not small, it's a big group. I'm used to going and speaking in front of rather big groups recently, and it's nice to have an intimate group. So this is a little bit odd for me. I'm not used to speaking to groups where everybody, speaks a different language entirely. If I am getting too fast, go with your hand like this, go like this, and I'll slow down so that my English comes across well. So the talk tonight is basically about something I've been spending a great deal of time working with, which is essentially working with legacy code. I wrote a book about this about 4 years ago, and this came about as a kind of like an outgrowth of work that I had done with teams that wanted to transition to agile software development. So everybody here has heard of extreme programming, I guess? You've heard of this? Okay, good. This is an agile group. You have to. So the interesting thing about this is that I got involved in this community back in the late 1990s. I had met several of the people who worked on the very first extreme programming project at a conference. And one of the guys I met, Chet Hendrickson, was on that team, and we were talking, and he said something like, yes, I always write the test before I write the code. Why would you do it any other way? And I thought this was a very strange thing to talk about writing tests before writing code, and he seemed so confident about this. And so I heard more about this practice, this new practice called test-driven development. And we've all heard of test-driven development? Yes, okay, good. Everybody does test-driven development, right? Yeah, okay, good. No, it's good to see so many hands. Of all of these practices that were originally part of a set of practices for extreme programming, I think this is the one which is the one which has the most power for going and keeping software development durable over time. It gives you a code base where you can not be quite so scared because you can make changes and find out very quickly through your tests whether things are working or not. So I met some of these early people working on the first XP team, and I tried test-driven development myself, and I found that it was very valuable for what I was doing. And so I became excited by this. And I was trying to do this at the company that I was working at. And I found that I was doing some of this, but some of the other people I was working with were not quite as excited as I was about some of these things. I left and became a consultant. And since that time, I've been going around to different teams around the world and helping them out with various issues related to transitioning to Agile. One of the things that I noticed early on, though, is that when you're doing test-driven development and you're doing it in an existing code base, often you run into a little bit of trouble. The very first XP team, they had a pretty good thing. They started their project over again, and they were able to go and start developing code with tests from the very beginning and end up with a lot of coverage for what they were doing. But most of the teams that I visited, where people had already been coding for a period of time, they had thousands and thousands of lines of code and not very much in the way of tests. And true, they could write new code using test-driven development, but they often had to go back into the older code and make changes. And they wanted to have the same confidence when they were making changes in the existing code as they did in the new code that they were writing. So tonight we're going to go and talk about different techniques for going and getting tests in place around the existing code. Kind of talk about the types of things that I'm seeing when I go out and visit various teams. These are the sorts of things that I tend to see all the time when I visit teams that have large amounts of existing code. I see teams that have software without much coherent architecture. It seems like somebody had some ideas in the beginning about what the code design should be, and then it seems like it's kind of degraded over time. I often see teams where basically we have lots of code, but it was not really designed for testability. And for that reason, it's hard to go and get tests in place now. The singleton design pattern, do you use this at all? Yeah, okay. Is it fun? Yeah, I know, singletons are kind of weird. They do have some odd situations or characteristics when it comes to testing. We're going to talk about that a bit more.
What is a singleton?
What is a singleton? Okay. What is a singleton? Okay, it is basically design. Are you being funny with me or no? Okay, that's the thing. So I'm going to learn over the course of this how much do I have to explain. Singleton design pattern. It's a design pattern in software. Okay, you know what? So everybody else, okay. So a singleton design pattern guarantees that you'll have only one instance of a class forever, right? Regardless of whether you want more than one. Okay. So singleton, I've also noticed in many teams I visit, extremely long methods. Sometimes I see people who have methods that have longer than 20 lines. Does anybody have any methods with longer than 20 lines? Okay, that was a joke. Okay. Typically, you see people that have thousands of lines long in their methods. And these are normal things that seem to happen in code bases when people aren't paying enough attention to the code in a way. Another thing which tends to be out there quite often is this, hard-coded access to external resources. So maybe you need to use a database in your application. And what you do is you have code which calls directly into the API that you use to talk to the database. Or maybe you're using a socket, for instance, and you create a socket directly and you use it. When I say hard-coded access, I mean that there's no easy way to replace this with like a fake or a mock for a testing situation. So these are normal things that happen out in the field. One thing that's interesting is that many of them are things that people tend to avoid a bit when they're doing test-driven development. Okay, and I think some of it is a natural side effect of doing test-driven development, and some other things are just a matter of people applying a certain extra amount of care. For instance, long methods. Can you use TDD and produce long methods? You can. You probably wouldn't want to, right? And if you have tests surrounding a lot of your code, it doesn't hurt at all to go and extract pieces out and make smaller methods. So these are the kinds of things that I've seen out there. And when you look at even worse cases, you find quite often that there are many large applications out there with code bases that have a lot of history in them. For instance, I visit a lot of teams that are working in C and C++. It's like in C++ in particular, there are many different eras of C++. Quite often you'll see people who have some C inside their C++ code. Or maybe they have some code that they wrote before they started using STL, or something advanced like boost metaprogramming or something. Any application which lives maybe 5 to 10 years, quite often will have many different technologies within it. And you end up having a lot of heterogeneity. You end up having a lot of differences across the entire application. Definitely true in Java, and it's becoming more the case in C# also. So I'm basically talking about these things to provide context for the type of work that I'm talking about here. When we have a large existing system and we want to start doing things with it, we can often have a variety of different goals with relation to it. One thing that we can do is we can look at our system and say, well, what we would like to do is we would like to go and completely redo its architecture. Okay? I'm calling this a system facelift here. It's like here we have something and it's kind of old and maybe the architecture isn't the best that it can be. And we're going to take, a couple of months or maybe even close to a year to rewrite portions of it and move it into a different large-scale structure. And sometimes organizations will do this sort of thing, but it requires a great deal of investment and a great deal of work. Another orientation we can have towards a large existing system is to say, well, our code right now is so large we probably can't change its architecture all that much. But the very least we can do is we can start to make our work easier within the code base, make it better over time. And this is the typical thing that we deal with in the Agile community of, the practice of going into the code and always making things a bit better through refactoring and things along these lines. There's another orientation that people often have towards large code bases, and that's to make fewer mistakes when making changes. And this is really a very conservative position. It's like, how often have you ever had someone go up to you and say, well, the code is not broken, so don't try to fix it. Right? It's kind of like, you can try to go and do something to make it nicer, but we don't want you to do anything which could destabilize the code and make it break. And often this happens because you have a very critical piece of software and nobody wants you to touch it because they're scared that it could break. So these are often, this is often a bad situation to be in. And one of the things about this is that often it is because you don't really have much in the way of tests. And this is why the fear is so high working in these areas. So for most of this talk, we're going to be talking about this central piece here. How do you start to make things a little bit better within the code base that you're working in? And this is not, how can I say, often as developers, we can always look at some system and imagine a way that it is designed much better, right? Has this ever happened to you? You look at your code and you're like thinking, if I knew back then what I know now, this would be a much better system to work in. Ever happened? Yeah, okay. And the thing that's really unfortunate is that we don't really get to start over again very often in software development. But what we are able to do is we're able to make changes in good ways from this moment forward and make pieces of the system better as we go along. So we're going to concentrate on this issue a bit. So you know what this is, right? Refactoring? Okay, yeah. So a series of small steps, each of which changes the program's internal structure without changing its external behavior. And that's really the goal for being able to work in a code base more effectively. We should be able to make the code better as we go forward. And the classic reference on this is the 1999 book Refactoring by Martin Fowler. It's a great book. It has a list of, I believe, 78 different refactorings within it. But he basically points out in the book that in order to do these things, you really should have tests in place to allow yourself to do these refactorings effectively. And once you have the ability to do these refactorings, then you are able to go from one structure to another. And instead of doing this in one very big, dangerous step, you can basically take it piece by piece. You perform some refactoring, you run your tests immediately to find out whether things have broken or not. Do another refactoring, run your tests, do another refactoring, run your tests, and you go all the way through, and you're able to go make things much better. But this is the paradox. This is the problem. Essentially, we should have tests in place to refactor. But I would be surprised if you have not experienced this. that quite often, if you want to go and get tests in place around some existing code, you need to do some refactoring in order to go and make that happen. Is it true for you? Yeah, okay. So what do we do then? Well, essentially, in order to be able to sort of break out of this paradox, we have to basically arrive at some techniques for refactoring that are very safe, okay? That we can do without having tests in place in order to go and get us to a position where we can put tests in place. And I think that this is something that is very important for us to realize about what we do as software developers. Many times people look at us and they say, oh, your job is to add a feature to the code, right? And this is quite often what our organization thinks about doing. And so they point out some new feature we need to add to the code, but our job is really much bigger than this. Our job, in essence, is to go and not only add that new feature, but also to go and keep all of the existing behavior working in the system. And this is really a very hard job for us. And if you think about it, this is why we think so hard when we are making changes. So we need to find that way of going and preserving behavior as we go forward and add new behavior to the system. And testing is an ideal answer to this in mind. Okay, so let's take a look at a little example. Okay, I'm going to show you something which is a little bit evil in a way. This is basically generating HTML using C++. And there's probably a few worse things than that. But this is a little example that I'm going to talk about a bit. Here's a class called PageGenerator. And it has a method on it called generate. And it talks to a results database. You're able to go and query for some results. You get the results back. Okay, here's some of the code. Okay, we essentially go and get back results from the query. And we were able to go and basically add things together here. We're going and building up a text page. And here's some more code. And here's some more code. Suppose you wanted to make some changes to this function. I mean, it seems like it's easy enough to do. You just go in there and you add lines of code, right? Suppose we want to be very careful about doing this. Well, one thing we could do is we could go and try to add tests to this. How would we test this? Just test it, right? It's easy. Yeah, we can go ahead and test things. But what we could do here is we could go and start to write a test for this. We'd have to populate our database with particular things that we can return back as results for our query. Which is going to be painful, no doubt. But we can essentially go back to start to go and write up some tests. The thing is, we have to go and have an insertion. The thing is, what should the expected value be if we're going to write a test for this? HTML string. It's probably going to be very, very long, isn't it? Okay, so we can write all this stuff, and then basically go ahead and say, we go our page generator, we call the generate method on it, and we go forward. How do we know what that string is supposed to be? What? Copying it from the output?
No, you can just run it for the first time. Just
Isn't that cheating? Shouldn't we be looking at our specification? The thing is, and I know I'm speaking to a crowd of people who've been using Agile development for a while, so you know which way is up. The thing to point out, though, is that there's something very different about doing the thing that you suggested, which is run it, and you run it, and I put the expected as just an empty string, and I run it and see what the HTML string is and put it there. And the thing is that this is not like normal testing. Traditionally in the industry, when we think about testing, what we are thinking about is going and seeing if our code matches some specification, right? I mean, we want to know that our code is correct. But if we do this thing of going and putting an empty expected value here, getting that big HTML string to see what's really happening, and putting that in our test, we're doing something different.
what we're doing is we're basically documenting the existing behavior of the system. We're saying exactly what it does right now. And this is a little bit of a different perspective. And I think it's important for us to recognize this. I call this characterization testing. What we're doing is we are going to write tests that will characterize or document the current behavior of the system. And the reason why we do this is because we have to preserve that behavior when we make our changes, right? There's a very interesting thing that happens in software, and that is that we may have some specification or some plan on how we're going to do things. But quite often we deliver that software out in the field, and has this ever happened to you that you fix a bug and then you discover later on that somebody was depending upon that bug and they thought it was good behavior? This happens sometimes. So in a way, when we take a system and we deliver it, it becomes its own specification in a way. So it's important for us to be able to document the current behavior. We may find when we run this and produce the HTML that we can see some bug in this. And then we have to look at this and we have to decide, is that bug something we can fix right now, or are we better leaving the test in and coming back to it later, talking to people to find out whether we should fix it now or not, or whether there's a different way of doing things. So this is a good way of kind of going forward with this. Now, getting a little bit more realistic about this, I wouldn't want to go and test things this way by going and putting the whole HTML string. It would probably be many, many lines. We could probably test by going and creating some custom assertion which searches for substrate within the context of this. And then we would be able to write tests for various things here. So let's imagine that we're going to do something concrete. We have to go and make a specific change to this. One of the things that you can notice if we look in here more deeply is that there is something kind of odd about the HTML table we're producing here. We have rows that are building up here, but we don't have any row which is the column header for this, which is showing all the columns that we are going to have. So we could go and write the code to go and do this. If we put it right here, between here and here, and that would be okay. It'd probably be about like 5 or 6 lines of code. Should we do that? Put the lines of code there? Well, I've got a question for you. Is this a function that needs to get longer? Is this function too short? How many people think this function is too short? Good, okay. So, it's like if this function is not too short, why do we want to make it longer, right? So the better alternative for this really is to say, we could put 4 or 5 lines of code inside of here. Maybe we are better off going and creating a function and just calling that function from here. That would be a good, decent thing to do. And the thing I'm going to mention about this is that this is actually a very good technique to use when you don't really have the time to be able to go and really start to get good tests around a particular function that you're going to work with. It's good to get some tests around a function you're going to work with, but sometimes you have functions which are thousands and thousands of lines long, and the time it takes to go and get those in place to be able to go and add some simple piece of behavior is like, you always have to work with that trade-off. So if you aren't going to write tests for this function, and you do need to go and add something to it, at the very least, what you should do is go ahead and write a test for a new function and call that function from within here. Okay? Am I speaking too fast? Should I slow down? Okay, I'll try to. Okay. So we want to go and call a function from here. Let's take a look at what that might look like. Okay, so we have our function H generator generated. And we're going to make this new function here called make header. And we're going to go ahead and basically call it from here. Now, this original function is now just 1 line longer than it was before. It's not 7 or 8 lines longer than it was before. Things are a little bit, they're a little bit worse, but we know at least we can write a test for this. It's a very simple test to see if we're producing what we expect to produce. But, you know, it is kind of artificial in a way, isn't it? That we go and create this other little function. You may think that, but actually it's good to go and make nice single atomic functions for things that we want to do. One thing I'm going to tell you now is kind of interesting. How many people here work in C++? Okay. Wow, more than I thought. Okay. I'm sorry. No, C++ is a good language. I like C++, but there are things that make it harder to go and refactor than other languages. It's a shame, I think. We have this, and there are some C++ teams that would not do this. And the reason why they would not do this is because if they make this separate function, and it is a function inside the same class, what do you have to do? You have to modify the header, right? What happens when you modify the header? Everything that includes that header has to recompile. Okay, and you know, with processor, you know, build times are getting better and such, but you know, there are some really big C++ projects where they've let their dependencies go bad. And because their dependencies between pieces have gone bad, it can take hours and hours to recompile the system. So for a change like this, to add in a simple function, they may just go ahead and make this a non-class function and just put it inside of the CPP file and call it from here. Or they might choose to do something different. Let me show you. So look at this. We're creating a class, okay, to go and make this piece of text and calling it from within here. Does that seem wasteful in a way? It depends in a way on what your coding style is, but sometimes people look at a class this size and they say, what's the point of having a class that small, right? The reason that people would do this, that people do this in C++, is because we can take this class and we can put it in a separate header, a CPP file. And then what we can do is we can include the header for this inside the CPP for the page generator. That should say page generator right there. We can include the header right inside of here. And then we are not going to be modifying the header for page generator. So we can do this. We can add this small little class, but it still feels like a little bit of overkill in a way, because we're introducing a whole new class just to avoid a dependency problem. Now, the thing about this, though, is it's not just an additional class, it's also an additional concept. In addition to the page generator that we are now going and introducing the concept of makers. This thing makes things, this thing generates things. Let's take a look at another piece of code here. What's the difference between this and this? Well, the difference is we renamed this class. This thing is no longer table header maker, it's table header generator. Okay? And the make function is now called generate. Does that make things better? Well, it's kind of interesting because what we can do now is we can see our design in a different way. We have our page generator, and it has a generate method on it. And what we can do now is we can say, well, page generator will use a table header generator. Table header generator. And that has a generate method on it also. So what we can do now is we can say both of these things can inherit an interface called the text generator. And this will have a generate method on it. And naturally, this is abstract. We have this, okay? And the interesting thing that we can do is we can actually say that instead of having a page generator just hold on to a table generator, we could say that in general, page generators can hold on to a collection of text generators. And they can be a bunch of different things. So we're actually going and moving towards a design where we basically are having that same concept being used twice in a way. So this is more kind of like a composite design pattern in a way. But the thing I want to point out about this is that you don't always see these things immediately. There may be things that you do in order to just go ahead and get past some problem, and you introduce a new concept in your code, and only later you discover that this concept can be merged into an existing concept. So this is an example of evolutionary design. You end up basically seeing something later that you can go and move together and make your whole design a bit more, cohesive, a bit more, whole in a way. So we shouldn't be very scared when we do things to go and get out of bad testing situations, because we know that some things can be made better as we go forward over time. The only thing about this, though, is that if you do this too often, you can end up with code that looks like this. Have you ever seen this before? Okay, and it's like, I don't know, I visit many different countries, and I guess in Russia they didn't have much in Europe either. This is a little thing that they used to sell in the US, where it's like a little ceramic or clay pig, right? And it has little lines sketched into it. And what you do is you put seeds inside the little lines, and you put water over it, and then you put it in your window. And then when the sun rises every day, shines on this, and you start getting these little sprouts that grow out of it. And it looks very funny, right? So everybody was happy in the US and they bought these things. But this is what happens if you start using these two techniques over and over again in your code base. The two techniques are things I call the Sprout method and Sprout class. It's like you want to go and add new functionality. You can't really get a test in place right now. So what you do is you create a new method. You sprout a new method. Or you go and you create a new class and you delegate out to these methods and classes. And you end up with this set of big methods that you've had in your code for a while that just delegate out little pieces of functionality. And it does look weird because it's not really uniform in a way. So because this is weird, we have to at some point get over it. We have to go and say, look, we do have these big methods. We do need to test these things. How do we start to test these very big methods that we have? Okay, so we'd like to write tests for some code that we want to go and change. The first step is always this. Try to go and create an object inside of the test harness of that class that you want to write tests for. So let's go ahead and take an example of this. Move over. Okay, so I have this little project here, and it's a Java project for something called a scheduler. And this is kind of like a calendar program, with a very old one and very bad code. And what we want to do is we want to start to make some changes to it. So we can kind of browse the code a little bit and see what's there. And it doesn't look all that bad. I mean, how hard could it be to test this code? I'm sure you've seen code which is much bigger than this that is easier to test. But let's take a look and see what's involved in trying to go and test this code. So I have here a test case. And what I'm going to do is I'm just going to attempt to create this class, create an instance of it. And we need to pass in some string, which is going to be the name of the person that this is a scheduler for. This is thinking, must be garbage. Okay, there we go. So we have that. And now I want to, I don't know, what we could do now is just run the test and see if anything bad happens. And that's often a good idea. Does anything bad happen? Okay, we have green. That's good. What could have gone wrong when we did this? Could something have gone wrong when I just created an object?
Some exceptions.
Yeah, we could have had some exception thrown from the constructor because some crazy dependency that we are not aware of was called in this code. But we're lucky here that none of that happened. So let's take a look back at our code and see what else is here. Suppose we want to make changes to this particular method here, add event. If we want to make changes to this add event method, what we ought to do is start to write some characterization tests to go and see how it works. So let's go ahead and at least just try to call it add event and see what happens. So I'm going to say scheduler add event. And what does add event need? It looks like it needs an event. So we have to ask what an event is going to contain. It turns out, let's see, if we look at the code for this, event takes a date. Does anyone remember date in Java? It's like that's the thing we had before calendar, right? It's a very old class. So we do have old code here. It also takes an integer. And if we hunt around a bit more, we discover that the integer is something which comes from this class called daytime. Is this a good Java class? It's kind of ridiculous, isn't it? So basically, somebody was trying to do something silly before we had enumerations in Java. But anyway, we have this old code and we have to work with it. We're going to have to go pass in the date. So I'll just go ahead and say date. And we have to go pass in a daytime. The value of the daytime. So we'll just pass in this. And right now, I'm not really thinking too much about what are good values to pass into this. I just want to go and try to get this thing to execute so I can learn more about it. And this whole process of trying to write tests for existing code is just that. It is all about learning how things work and then basically recording, in a sense, how these things work so that you can add features and refactor without breaking things. So we need to go and create a date. And right now I'm just going to go ahead and create a new simple date like this. And it looks like we have, we're going to import this ancient thing. Let's try to go and run this now. Okay, it looks like it passed. That's pretty good. There's something odd though. There's the I'm not getting the output, console output.
Window.
Window, right? Should view the outputs. Console output. So. Let's run. There's something, oh, you know why? Because it is never saved. Strange, there's something.
Maybe there's no
Sorry?
nothing printing.
Yeah, the thing is, there should be something printed there. Yeah, I'm supposed to get all this garbage on the screen. And make sure that I'm running the right test. I don't know why this is happening. Supposed to be getting strange console out there. Yeah,
Do you have the records?
maybe debug this problem.
If you open console, let's try to see drop down list in the console. What the console consider?
Maybe down here?
Right.
Here? No? Yeah.
We made a deletion.
How do I separate this thing? The breakpoints in the channel. Sorry guys. Okay, so yeah, I'm really concerned about this.
Готово, что я могу.
Потом запись смотрю, была ошибка. Сейчас не сила.
Терабласт.
Как раз полтора часа прошло.
Где эксперт?
Только сейчас сразу не можно, я съел его.
Yeah, there was something strange with this. Alright. I'm sorry guys, I feel like I'm running out of the game and 10 hours time difference and it's crazy. Okay, so go back to where we were. Alright, so we had this test. Schedule test. And we were just going and executing at event and seeing if anything crazy happened. And then of course, something crazy did happen. Okay, we have all this stuff here, still printed out. And you know, what's going on with this really is that there is code in here that that prints these crazy things out inside of this class here called scheduler display. And we can see this happening inside of here. Okay, we have a scheduler class, and notice over here it creates a scheduler display. And when we have that scheduler display, it looks like when we actually call add event, it goes and shows an event using that display. Now the thing is, you would not expect us to see code exactly like this in any type of an application. It's kind of ridiculous. But the thing is, and this is really just code that's in here, standing in to go and show us the kind of thing which could happen, which is that we could have some code which is, you know, it causes something crazy to happen, like a GUI action or displaying a dialogue or something in the context of what we're doing. So how do we get past this problem? Well, it's funny, we're kind of stuck now because we are creating scheduler display inside of the constructor, right? So one way to get past this would be to go and actually pass in our scheduler display, right? And then we can do this. Is this a good idea? Passing the scheduler display?
Yeah.
You just wrote the constructor.
I just wrote the constructor, right? Yeah, I guess the thing is that every place that we use a constructor now, we would have to go back and modify the code in that place. But what we can do is we can leave a constructor that has exactly the same signature. Okay, so we have this, and what we can do is cut this out. This is exactly the same signature that we had previously. And what we can do now is just say this owner new scheduler display. And this code should behave exactly the same as the code that we had previously, right? Now, the thing about this to deal with now is we can go ahead and introduce an interface. Could we do this though? Could we subclass this class and override this particular function? Do this. Yeah, sure. An interface is good, but could we do the other thing? Could we subclass this class and just override this function? We could do that. And sometimes that's actually a decent way to move forward in languages where you don't really have an automated tool for doing extract interface. You go into subclass and override things in production classes. The only thing about that, though, is that there is one problem with it, right? What's the problem with going in subclassing the production class and overriding something so that the test can still pass, the test can pass?
And the behavior can interfere.
Yes, the behavior can interfere. Somebody could go into this class and make some change, maybe to its constructor or something, which would cause your test to fail for a reason other than the reason that you are hoping it would fail for. So yes, in general, it is better for us to go and introduce an interface. So I'm going to go and say, extract interface for this, and we'll just basically make a display. And as we do that, we're going to let it go and replace that all the way through. And we have this. And we can go inside here now and actually go ahead and change our test so that that stuff won't happen, just by going and introducing like have that, and this is simple enough, and we just go ahead and create an instance of our new fake display over here. So this is not by any means the full-blown mock object, but we're just basically going ahead and introducing this so that when we run, we simply do not have that problem happening at all. It doesn't happen in the console. Okay, so we've made things work a little bit differently now, maybe a little bit better. We've nullified some behavior that's part of this. Okay, so let's look at this a little bit closer. Looks like we're going to have another problem here, though, too. This guy's going to get very upset with us. Who is this guy? He's the guy who receives email every time we run our tests. Should he be receiving email every time we run our tests? Probably not, right? So how do we get past this problem? Huh? Move to configuration. You know, we can try to configure the address and stuff like this. The thing is that configuration is good for changes you want to make that are variations in your production system. Sorry? Create a mock class. Yes, we'll have to create. We could create a mock class. And if we created a mock class, well, let's take a look at this. We have mail service, and we're getting it from here. What's this? Singleton, right. But we could do this. We could go ahead and supply it as another constructor argument. And that would be, okay, it would be just like doing what we did with display. The thing is that that's not the only choice that we have here. We could go ahead and we could go back to our singleton. And we could do something a little bit different. Let's go to singleton mail service here. What about doing this? Does anybody feel that this is bad? Sorry?
You've got to create direct plus.
Yeah, so we have to go make this protected, right? To do this. Or, you know, what we can do as well is basically go and make this into an interface or something, and hold on to it as an interface so we can substitute one in, or something along those lines. But this particular technique bothers many people. You know, they don't like the idea of going and providing some function which allows you to replace a singleton instance for testing. And I can understand why, you know, because the purpose of singleton is to make sure nobody can create a second instance of any of this stuff. But in testing, it's nice to be able to go and replace behavior, particularly if you have a singleton which could have its state modified inside of the test. If the state is modified inside of the test, then in later tests, you may end up having corruption because of some other test. It's possible that state from one test could go to other tests, and we really want our tests to be independent. So if this is the case, then you know, we could do this to replace this. But like I said, some people don't like this. In some languages, you can do conditional compilation to make sure that this is only possible in a testing situation. But one thing to think about, though, is that if you're working on a team and you know everybody who's going to be working in the code, it isn't like you're interfacing with some external system, then what would you think about somebody who would call this method in production code? This is the person you would probably want to take outside and beat up, right? And then they would never do it again because you would beat them up and they would remember. Never call a set testing instance in production code. So the thing I'm pointing out, though, is that protection that we built into our languages to protect ourselves can be good, but we have to remember that much of this is a social issue. It's like, how do we make sure people don't do a bad thing? And do we have to use the keywords of the language to prevent certain things which could just be told to people? Now, if you're working in a team which interfaces with another team, and you have no control over those people, then maybe you need to use language-based protection for things. But I just want to show that this is an option with some of these, with some systems. So I mentioned also that we can go back in here and we can go and add another argument to our thing here. I want to show you one other possibility that does not occur to many people. They do not think about this. But suppose that we did this. We can go over to our mail service. We can copy over the parameters that we have. And we can go into this method. And what I'm going to do now is just basically create a protected method here called send mail. And I'm going to drop over these parameters. And I'm going to go and copy over this line of code. Put it over here. And copy over these parameters. And what I'm doing here is making a simple delegator for this. Does this do us any good at all? Good. It's not doing anything for us that's good right now, but what if we do this? Okay, so now we're delegating over to the send mail function, which is on ourself. And when we have that, we can go into our tests and we can change things around like this. We can say, let's have a testing scheduler class. Okay, and I'll just go ahead and create it here. Okay, so we have the constructor. What I'm going to do now is I'm just going to go and override this particular method, send mail. And it, of course, tries to go and have me call super. I'm just going to go and get rid of that. Okay, so now that we have this, Jock will not be receiving any mail. So how do you feel about doing this? A bit dirty, yeah. It isn't as clean as some of the other things we looked at. But the thing I wanted to point out is that this is a possibility. And you know, sometimes you're working in very, very big classes, and you look at it and you say, yes, I can add another argument to the constructor, another argument to the constructor, and do this. But you realize that there's only one method, which is going to be using the mail service. And this is a way of going and actually getting past that issue. So you can go and do this, you can subclass and override in the test. This thing of going and extracting functionality and then subclassing and overriding the test is a good way to go and start to break out dependencies on external items when you have many of them of different kinds. But you know, in general, I do prefer to go and add parameters to the constructor. An interesting thing to notice, though, is that there are really three different scopes that these three different techniques have. You know, one of them is that we have, if we basically go ahead and use the singleton technique, what we're going to do is we're going to replace that behavior for a whole set of classes. So the scope is really global. If we use the technique of going and parameterizing the constructor, then basically our scope is going to be just for one class. And if we do this technique, which is basically going and extracting method and overriding, then we're going to basically just be dealing with one particular method on one particular class. So you can basically choose the scope at which you're going to break these dependencies, and it's important to go and think about the cases. If I have this big code base where I'm using the mail service in 15, 20 different places, I'm probably going to want to lock it out in a singleton just to be able to go and get rid of the problem when I'm doing my testing. When I know that I'm going to be using a couple places inside of the class, I can go ahead and parameterize the constructor, and then I know that that class will be independent of the mail service. And I can do the same thing if I just have one particular case. One thing that is nice, though, and the reason why I think we should overall move towards parameterizing the constructors, is that, in essence, this starts to make the code more explicit. You start to, as you do this, document in the code exactly what is being used in the